Today we're going to look at applications, and as you can see, this has been a unit that is really heavy on your knowledge skills because it's all about building your algebra skills throughout this unit that are going to help you for the rest of your math career. So applications are pretty scarce in this unit, so I'm going to just give you a couple of examples of how you will see them on the unit test, okay? So first we have this box shape with a shaded area. You've seen these before. And now I want you to write an expression in fully factored form that represents the area of the shaded region. So obviously, as we've done in practice, you need to first come up with an expression for the area of your shaded region. It's important that you do tell me you're finding the area as well. And of course, you're going to take the area of the large box, which is 4x times 8x, and you're going to subtract the area of the smallest box, which is 2y times 4y. Okay, and that is the expression for the area of the shaded. This would be what we would call the fully simplified area of the shaded, and there's nothing much you can do with this else in terms of simplifying it because there are no like terms or anything like that. So then, to actually factor that expression, okay, we could common factor in this case. It looks like just an 8 is common because an x and a y aren't common to both terms. So there's just an 8 common to both. And then when we common factor that out, okay, we get 32x squared divided by 8, which is going to give us 4x squared. And then for our second term here, when we're common factoring, we have 8y squared divided by 8. So we're simply going to be left with our subtract y squared. Okay, so this is now what we call a fully simplified expression for the area of the shaded region that is then factored. So sorry, this is the simplified expression. This is the then factored expression representing the shaded area of that shape. Okay, let's take a look at another one. Okay, so here's another question. This one without a shape, but sort of given in words. Hopefully you can imagine this. This would be where you have an area of a rectangle. Okay, we know that the area is given by this expression. You've been finding these expressions many times. And we are asking you to determine a possible expression. It's going to be a binomial for the length and a binomial for the width. Okay, so what do I have to do? I have to take my expression, 3x squared plus 10x plus 8, and I need to factor that, okay? And we know that that's a trinomial. It's going to look like this in terms of two binomials. It's actually a tricky trinomial because of that 3 right there. So I'm going to set up my staircase method. Okay, I'm going to put my 3x squared up here. I'm going to put my 8 up here. I'm going to put my 10x here. I know possible factors of 3x squared is only 3x and x. Those are my only options. And then for possible factors of 8, I have 4 and 2. And it seems like 4 and 2 are going to work, okay? Note that both of these are positive. Okay, so I think that we are going to end up having 4 and 2. I'm going to try it like this. Okay, and then if I cross multiply here, I would get 6x, and cross here, I would get 4x. Okay, just to show you, sorry, the 3x times the 2 gives me 6x, the x times the 4 gives me 4x, and I know I actually need them both to be positive to give me positive 8, and here 4 plus 6 to give me positive 10. So there I have my factors. So I have my 3x plus 4, and then I have my x plus 2. Okay, so this is obviously a possible length, and this is obviously a possible width. Does it matter which one's which? Not really. You don't really know until you actually put values in. But just like we always say for our box, it doesn't matter which one's length and width. But these are both expressions that represent the length and width for a box with that area. Okay, so hopefully those make sense. You're going to practice a whole bunch more of those in class. And then there is sort of one other type of question. So I'll show you this question right here. This is one other option, okay, and these are then determine the value of k. Notice they have a value missing, so that the following trinomials, when factored, are perfect square trinomials, okay? So this takes a little bit of remembering that a perfect square trinomial, remember, is a perfect square here, a perfect square here, and when we factor them, they actually equal a binomial squared. Okay, very, very easy to factor because we simply take the square root of that term, which is x. We take the square root of that term, which is 3. And whatever the sign is right here follows. So it would be plus 3. Okay, now in terms of thinking about what k would be, of course, if we were going the other direction, if we were expanding, we know from earlier this unit that to find that middle term, we would multiply these two together, so that gives us 3x, and then we would double it, right? It's that 2ab, if you like, that middle term, the middle term equals 2ab. So in our case, our a is x, our b is 3, so we actually get 6x. Okay, and that tells us then that this value right here should actually be 6. Okay, so again, I'm thinking about going the opposite direction, right? I'm factoring that, okay? Let's try the other one. This one's a little bit more complicated. So if I'm thinking about factoring this one, I recognize right away that that's a perfect square, that's a perfect square, okay? So I know that it equals a binomial squared when factored. I take the square root of the first term, which is 2x. I take the square root of the second term, which is 5, and it's positive because the signs are all positive. Okay, now thinking about, so this of course means, let me fill this in again, that a is 2x and b is 5. So the middle term will be 2ab, which is 2 times 2x times 5. Okay, which is going to give me 20x. So this means that k is 20, looking back to my original equation right up here. Okay, and let's double check. We know that when we go the opposite direction, when we expand, we take this, we take this times this, so we get 10x, and we double it to get 20x. So that should match up there when we're thinking about going both ways. So you're going to also try some of these in class. And hopefully this really helps you understand what it means to be a perfect square trinomial. Whichever direction you're going, whether you're expanding or whether you're factoring, it will help you to understand that. Okay, so we'll practice some of these in class. Make sure you've written these down as examples for yourself so that you'll be able to use them to help you with the textbook work tomorrow. Thank you.